Good evening. Today we're going to talk about functions and relation. A function is any set of ordered pair. The set all x components of the ordered pair is called the domain of the relation, and the set of all y components is called the range. So, all the x components is called the domain, or as usual, it's called the input of our domain. Our function. And then all y component is called the range, our output of the function. Today we have here, for our example is number 1, we have 2, 6, 4, 8, 6, 12, and 8, 16. So we're going to find the domain, each of them. So all x components are 2, 4, 6, and 8. So our domain is 2, 4, 6, and 8. So now we're going to find our range. So all range components are y. We have 6, 8, 12, 16. We have 6, 8, 12, and 16. So that's how you find the domain range of a function. So in number 2 we have negative 1, third, negative 1, 3, negative 2, 2, negative 3, 0, 1, 3, and 4, negative 6. So we're going to find the domain first. So we have negative 1, negative 2, negative 3, 1, and 4. So our domain is negative 1, negative 2, negative 3, 1, and 4. And our range is 3, 2, 0, 3, and 6. So we have 3, 2, 0, 2, 3, and 6, negative 6. Okay, moving on. Now, a relation in which each number of the domain is paired to exact one member of the range is called a function. So here's the examples are number 1, a, we have 1, 2, 2, 3, 3, 4, and 4, 5. So in this particularly number 1, we have a unique set of input and output. So in our we're going to find if they're function or not. So in number 1 we have 1, 2, 3, and 4. Number we have a unique input and output. So number 1 is a function. And then As for number 2, we have 2, 2, 4, 4, 6, 6, 8, 8. A unique set of input and output. It's still the same way. So number 2 is a function. Okay, now we have here on number 3, we have 1, 0, 0, 1, negative 1, 0, 0, and negative 1. So as you can see here in our domain, we have 0 and 0. Yes. Then in our range, we have 1 and negative 1. This particularly is not, it's which member they need to be exactly paired to one exact member. So the domain needs to be paired to exact one of the range. So number 3 isn't a function. Now we have here a representative of a mapping, which is the same as the example earlier, but it's a mapping of a function. So as we can see here, this is our domain, this is our range. Inside of our range is 1, 2, 3, and 4. Inside of our domain is 1, 2, 3, 4, and 5. And our range is 12, 13, 21, 29, and 35, which is normal actually because they're quite paired one to another. So this is a function. Now number 2, we have x. We have 2, 4, 6, 8, 10 on our domain. Then in our y, our range is we have 2 and 4. So in this example, we have 2 and 10 paired to 2, and then 4, 6, and 8 paired to 4. This is an example of a function because they paired one to another, which is quite exaggerating, yes. And then we have 3. As you can see here in our domain, yes, we have 3, 7, and 9. And our range is 31, 55, 22, 19, and 15. As you can see here now, on 3 and 7, they paired 2, which is 13, 15, and R7 is 22 and 19. So this is not a function. We also have here a graph, meaning to say na yes, a graph. Wow, magic. The joke lang. Given the graph of a relation, easy to identify its function or not by using a vertical line test. So, as you can see here, a graph mathematical equation graph to be function if a vertical line draw passes to the graph, touch the graph at the exact only at one point. For example, right here we have a vertical line. graph. We can draw lines like this. So we have a function. Yes, this right here is a function. So now right here we have, I forgot what graph is this, but for now we're going to draw, and this is not a vertical line by the way. So now we're going to draw a vertical line, which is quite the indeed needed example. So right here we have point over here, point another here, another point there, many points. As you can see, there are quite many points. Yeah. So to knowing that this is a function or not a function is that only one line can passes to the graph at exact one point. So this is not a function. So right here we have a parabola. So we can just draw a line that passes the line of the parabola. So I have another point there, here, here, and then so this right here is a function, and that's pretty much it. Thank you and God bless.